Okay, let's get started. Good morning, everybody. Welcome to PyCon 2014 in Montreal. The first time not in the US, as far as I know. So we're kind of starting off the conference with tutorials here. We're going to look at descriptors and metaclasses, one of the maybe not that simple topics in Python. First, I would like to introduce myself a bit. My name is Mike Müller, and I'm from Python Academy, and I do teach Python. So I do here, and what I do for a living most of the time, teaching Python. I discovered Python back in 1999, so it's quite a while ago, with version 1.52. And ever since I use Python, and in 2004 I started teaching Python, and I teach quite a few of classes. And I think if I'm counting right, this is my tutorial number 14 at PyCon here, so it's quite a few tutorials I've been teaching so far. I have another one tomorrow, so. Okay. First, I would like to ask you a few questions about your Python experience. So it would take way too long after everybody personally, because otherwise we only have 3 hours, so it will be over. So who of you is using Python less than 1 year? A few people? Less than 2 years? More? Less than 5? Majority? More than 5? Yeah, so it's a mixture of people. So that's very typical. Descriptors and metaclasses are topics that you can get away without knowing for quite a while and still write good Python programs, but we're going to look at a few things here. All of you should have a handout. There's a piece of paper on the table, so I put them, pretty much every seat should have a piece of paper. This is a handout, and we're working with the handouts. And all of you should also have downloaded this thing. So I sent a mail around. Hopefully everybody got it. Did you get it to download? Yeah. So if you can do this now, the Wi-Fi is PyCon 2014, and the password also PyCon 2014. Everything lowercase, no space. So that's actually the password here, right there. And just download this material because we're going to work with a material. If the download doesn't work, maybe you can also share with your neighbor or something. It's a small download, it's just a few Python source code files, so it's not a big thing, just a few kilobytes we're going to work with. Good. Who of you is working with Python 3? Just a few. So most of the people are with Python 2. I'm also with Python 2, but pretty much all the material I have here should work with Python 3. So I tested everything with Python 3. Only when we come to metaclasses, the syntax is a bit different. So you need, from time to time, there's a version for Python 2 and Python 3. But typically, pretty much everything we cover here will be valid for both courses. Okay, we're going to have like 1.5 hours, and then we have a break, and then another session. So the first session we will cover descriptors, and the second one metaclasses pretty much. And there's a break in between. At the end there will be a survey, so I will give you the link to SurveyMonkey, so they ask you to fill in the survey, which is important, that you give us our opinion about what we can improve or what was good about this tutorial especially. Okay. I'm working with IPython Notebook. Who's familiar with IPython Notebook? A few people. So if you don't want to, you don't have to work with IPython Notebook. It's not strictly necessary here because everything I cover works without. It's just nice for me to present. If you feel like it, just can install IPython, and I work with IPython Notebook here, and I just type IPython and space notebook. If this works, then you have nice IPython Notebook installed. If it doesn't work now, you don't bother. It doesn't matter too much. You can just work with a normal interactive prompt and with a editor. Okay, so I have all this. I just deleted them. A bunch of untitled here. So I just make a new notebook, and I renamed the first thing. I renamed the notebook, so I know. So this is purely for showing you things, because it's nice to have this interactive. So this notebook is a mixture between the normal IPython, which is an improved interactive prompt, and a notebook where it saves everything. So everything I do will be saved, so it will be nice later on. I can also later on upload this notebook for you, because I will do a bit interactive things, and if there are some questions, I always answer questions. So if you feel like in between, please ask questions, and I will try to answer. If it fits, if it doesn't fit in the context, I will maybe postpone later. We also will have exercises, so I think it's important to have exercises, because if I always tell you things, everything is very clear, and then you start doing yourself, they're getting more complicated. So therefore this tutorial is not as dense as maybe others. You see also the handout is pretty thin, so I don't cover too much ground, which is intentionally. So of course we want to do exercises. So let's come to descriptors. That's our first topic. So because this is also nice, you can use this and you can change this cell and the cell type, and I can make it a heading here, and then if you press Shift Enter, I have some heading. Okay, before we come to descriptors, I would start with properties. Who worked with properties before? A few people. So properties are an application of descriptors, because descriptors are the way in Python how to access attributes. And when you work with Python, actually you use descriptors all the time, even though you don't know the terminology or anything. But as soon as you work with methods and things like this in the background, you work with descriptors. And therefore, we start now with properties, which is maybe easier access to descriptors. Properties would be our first topic, and you are encouraged to type along. So I typically don't type too fast. I always make some breaks and talk. So it helps if you want to type along. Just the short things, longer things, we have this source code just downloaded, and then the both this big example doesn't make sense to type. Makes sense to type all of them. So we're gonna work with this pre-programmed files I have. So them source code files. So what's properties all about? Properties is one way in Python to get rid of getters and setters, which is something you don't write too much in Python. You want to get and set attributes to instances. Therefore, properties can be helpful, and there's maybe an easy explanation for descriptors. So let's start with a square. Everybody knows what a square is. So we are on Python 2, so you have to inherit from object, otherwise it wouldn't work. So everything we do, we need new style classes here. So in Python 2, to get a new style class, you have to inherit from object. If you're with Python 3, it doesn't really matter, but it doesn't hurt. So I always put it in so you make your code potentially work with Python 2. So that's what I'm doing lately anyway. I write my code that it works with Python 2 and Python 3 with a single source. Works to 99% of the time. There are a few small difficulties sometimes you have to work around, but there are good packages that help you. One package called Future that helps you to get things right. So first I define what my square is. So a square is very easy. It has a side, and then I just assign, as you would always do in the constructor here, in the init, I assign side to self. And then I write 3 methods. Actually, you get away with 1, but I write 3 methods. I just show you the way it works. So I write 3 methods here. One is called a get, and this one just doesn't take any argument then when I call it, and I just return self side times self side. So this is a definition of the area, as you might know, of a square. So both sides are the same. And I also define a set, and just for simplicity here, I don't allow anything to be changed with this method. So we'll see in a minute what it's good for. So a value, and I just print things out, and I say, this is if you put the parentheses, it works with Python 3, and so here it makes sense to use double quotes, and can't change. something like this. Yeah, so it's just as an example what you can do. And the same thing, I have a delete method, which is also not doing anything. So usually just delete without only the self, and I can do the same. I can just copy this over here and put it. I just make a bit more space here. Just turn off those bars here so you can see a bit more what I'm doing. By the way, is it big enough in the back of the room? Can you see? The font is big enough? A little larger. Okay, I make it a bit larger, like this. Okay, because if it's too big, yeah, I cannot type. You cannot see much. So, and this is just what I'm doing. And now the thing is, the classical way to do a property is use the built-in function property. And now so far you don't see anything what it's all good for. But now I say area equals, and now I use the built-in property, and then I just have to throw in those three methods in this order if I don't name them. So I put this in, and then I write a doc string. So that's always a good idea to write doc strings. So you write doc string, you call the doc area of the square, something like this. So this would be, see, now I have a big problem to get everything on here. This would be the way to do it. And now we have this property, and now you can use it. You can make an instance of your square and just give it a side. And now you can just access area, and you get the 25. So there's a magic that's happening. When I access area, then this area actually it's a property, and then things going on behind the scenes. And this is calling the aget method, as you see, because I put in 5 times 5 is 25, so that's what is returning. So since I overrode I also defined the set and the del, then if I try to assign, then if I say, okay, I want to do something like this, then I just get this message in this case. You can also raise an exception, of course, or something like this. If you don't define it, it will do it anyway. But so now you can also use the delete. So if I try to delete the area, I cannot delete the area. So that's how properties work. Yeah. No. That's just names I make up. You can, you have to. If you look at property, look at the help of property. So if you go, I use position arguments. This is the help here, and it tells you. See, you can name them. You have to name fget, fset, fdel, and doc. That would be the names, but I use positional ones. You can also use names, and you see if you don't use any of them, there are none, and nothing would happen. So you just very often it's good enough just to have a getter, the get. That's a common case, and you don't want to delete anything, then you don't have to do this printing what I did here, and the doc you can do. So this would be the way doing it. The traditional style with built-in property, which can be nice from time to time. The problem is now you kind of hide the fact that is a property just here, because you have to define those methods first before you can use them. Then you hide this important fact that's a property just down there, and that's not very Pythonic. One of the Pythonic approaches, you want to have the most important thing on top. A lot of places you want this, like if you have a range instead of a while loop, you want to have everything on top. Or if you use enumerate or zip, or those things, they always help you to put the most important things on top. And this is not somehow, if you program Python, you say this is very important, but you have to dig through the whole class, and this can potentially be at a different place. So there's another way to do it, and I have it in the file. So if you go to if you unzip this what you downloaded, and I can do everything here in the iPython notebook, which is nice. I don't have to go to the shell. And here I can see I have this this file. I don't have this file. Could it be? Oh yeah, of course I don't have it because I didn't give it to you because it's in a different directory. That's not good. So I have to, of course there's a directory properties and I didn't give it to you because I put in a different directory. Just a second, I need to copy this over and I will upload it to you. I just show you now, but I will give you, upload it in the break, I will upload it. This always happens. I will upload it to you. There must be a properties directory. Yeah, there we go. And I didn't put it over, which is not nice. So, just a second. I will be right there. Okay. Yeah. So. Okay, suppose I put properties in diff directory, and I thought it would be in descriptors, but it's not. But you will get it. So I'll just show you how to do this. It's printed in the handout, so you will be able to follow. So if I'm in properties now, though there are different ways to write a property. So the traditional way would be this would be the one I just showed you. That's what I just typed. So you have this way doing it, and you see I have this way hiding the property down there. That's one way of doing it. The other way would be the newer way with a decorator. So instead of hiding the fact that area is a property, you use a decorator, and this decorator is named property. The built-in function property also works as a decorator, and this is no surprise, it's just a different syntax, but doing the same thing here. In this case, you just have this property here, and now you just can define a method that's called area, like you want to call the property later on, and this would be the getter, sorry. The get method would be this one, and that would be pretty much everything you need here, and you would be done. If you want setters and getters, you use this thing you call another decorator, which is area. So obviously this has to be after this one. You see, all of them are called area, all these methods, which is kind of strange because if you know in Python you can only have one method with one name, but here they are different because you have this decorator. So you use the same name, and then you use this same name area setter and deleter here to actually have the same effect. This would be my a get, this would be my a set, and this would be my a delete. But it's very obvious that this is a property. Very often you don't need those two. So if you only want to get, then it's fine, just use property. And you use property, and then when you use it, you will see the same effect. So I have this here and here, and if I do this, you will have the same effect, though you cannot delete things because I overrode it. So both of them are the same, but it can be pretty useful to have this very important fact. It's a property written right in here. And I think that maybe in most of the cases you'll find just using this property as it is, and you don't care about the setter and deleter, which is pretty common actually. But if you want to, you have to use the same name, and this one has to be first, obviously, though this area exists before it's getting there. So you have to have it work like this. So that's a new way of doing it with a decorator. Actually, I found a way which is a bit nicer, because now you still have the three methods that actually belong together, but they are on the same level. And it's a little bit strange to read, because you have to know that all those three belong together, and the only thing that indicates is the same name here. So there's even a nicer way doing it. You can use this small recipe I would like to show you, which is called nested. Nested. It's also printed there. So, and I have a small helper function here, which is actually doing something. we make this simpler. We have this small function. So you see what I'm doing? I just still have the same constructor beside, and then I use my nested function here. And you see, I put in this area, and I call this and get the names back, and I do things. So to look at it makes sense. Look at the thing. So I use 3 now nested functions. So because you can, or methods actually, functions inside there. See, you can do this in Python. You have these nested ones, and they are defined on the fly. Now they have to be called fget, fset, and fdelete, because I need those names. And then you see I return locals. And locals returns a dictionary of these names with the objects in there. So maybe later on we can print the locals, how it looks like. And this dictionary will be handed in this nested property here. This is what's coming here. That's the area method. And it's called, and it's actually returning these names. This is a dictionary. And then I just set the doc string here. So from this doc string will be used as a doc string. And then I use my property, and I use this syntax. So there's another magic here. I take my dictionary apart again and supply it. Okay, that's a bit magic. Let's first check that it works, and then we look at a few details. So you see, it's doing the same thing. And to understand it might make sense to at this place print the locals to look what it's doing. Locals, and you see if I do this, then you see now this is locals, but it's printed. It's a dictionary, and this dictionary has its 3 names: fset, fdel, fget, and has the functions that are just defined in there. Yeah, so that's what I return. So that's what I have here. And now I get these, exactly this, because I return it, I get it into this function up here. And now I can poke inside. I just use, because I don't have a docstring extra one, I use a docstring that comes with a function. So this double underscore doc here gives me the docstring of the function, which is this docstring, because I want to have the docstring. And then I just use property names, and then this one takes this dictionary as keyword arguments. So you might be familiar with the double star syntax. So a double star syntax takes a dictionary as keyword arguments for a function. So now actually, this would be the same as I would write it by hand if I would write property, and I would say fget equals fget, and so on. Fset equals fset. And so on. It doesn't work now here, but that's what it's actually doing with a double star. It's just handing this over, and then you're all set. The nice thing about this here, that everything that belongs to this property is inside and is nested. So it feels a bit nicer, but it's one way of doing it. And it's not really magic, it's just plain Python. The only thing you have to really use these names. You have to call it fget, fset, and fdel. Okay. These are properties, and they are good enough for a lot of purposes. The generalization, actually, you can think of it as a generalization, would be the descriptors, our topic we want to talk about now. Descriptors are more general than properties, and they, yeah. So actually, it's everything that comes with Python, but you should write a documentation for it. So I'm not sure. It looks nice. It's not documented. It's not like in the standard. You say, okay, just look at the Python doc so you can read it. It's something that's a bit different. So in general, it's not too difficult because it just uses a concept of a decorator and the concept of this nesting of the function, and then this double star thing. So all the parts are standard Python, but how to put them together, it's a bit different. Yeah. So it's always a question. It's a bit magic, a little bit. Yeah. So it can be nice. The thing is, you should really document it and say what it's doing actually. So then people, even if people don't understand all the details, if they know it's doing the same thing as writing the property out, should be fine. That's, yeah, it's always a judgment call, who's going to use it and what you're going to do with it. Thanks for your question. Okay, let's come to descriptors. So I take this away. This is just the explanation. Descriptors. So we have two types of descriptors, data descriptors and non-data descriptors. Actually, the difference will come out soon. If you have a class, so let's look at a descriptor, how a descriptor looks like. I have a typical data descriptor, and for this one I have a file, so I can go up to my descriptor. Now you should have this descriptor directory, and inside the descriptor directory I have a data descriptor, and I can look inside here. Yeah, and this is a typical data descriptor. I need to talk a little bit until it really makes sense and you can see what it's all good for. So a data descriptor is a class that has these three methods. So you have to have this get, set, and delete with a double underscore, the standard methods. And as soon as it has, it's called the data descriptor. Okay. And then it looks a bit strange because here this data descriptor doesn't make sense by itself. It has to be used from inside our class. We will see that in a minute. And this get method here gets an instance, obviously, and the class theirs belongs to. And the set method gets an instance and a value, and the delete method gets an instance. So this thing on its own doesn't make too much sense. It only makes sense in context we will see in a minute. So, but the get is just returning the value which we set to 0 in the beginning, and the set is setting the value here, and I cannot delete it. So it looks somewhat, the feeling is somewhat similar to a property, to what it's doing, but the usage is a bit different, because this class usually you cannot use anywhere, you can only use inside another class. So let's make an example. So I define this one here, so I can do this since I loaded the file. If you're in a normal Python interactive interpreter, you have to import this file and then you can use it. So since I loaded it, now it will be my namespace here, and I can say I make a class which I call strange because it behaves a bit differently. So strange, which inherits from object, which is important. And now that's how you use it. You say an attribute is this data descriptor. So that's typically that's pretty much the only place you can use those descriptors inside the class, and they will be responsible when you access this attribute, what I call here, and I just make an instance of this thing, and now I have my new class, and now I can work with the class, or I can work with a with the instance of it, or make an instance of it, and now I can access attribute here, and then you see what's happening. I get the 0 and I get my text I printed here. So if you look at the source code, that's what happens. It just prints what I put here. So if you're in Python 3, you have to put the parentheses. So I've forgotten to put the parentheses there. And around the print. And now that's what's happening here. So I get, at this place, I get this method executed. So if I have this attribute, which is an instance of this data descriptor, and when I access it, I get this this get method executed here, and I see my print, and I get my value returned. Since I didn't set anything, it's 0. I could have set it in the beginning. So, and now you can very fine-grained regulate when people access this attribute what's going to happen, and that's what descriptors are good for. So, and actually, now let's see what's happened. So I get a little bit more deeper inside. First, if you have this instance S, you can always get the class. So if you say type S, it gives you type S gives you the class. And now we have the class. Inside this class, so I have to also you don't do it every time. Inside the class, you have a dictionary, and this dictionary contains everything. It's a proxy, so you can only read. Actually, you can only write anything. You don't want to actually, but you can access it, and that's what Python is doing. It looks inside this dictionary, and then it just gets out the attribute. So That's what happens here, the attribute. And then it calls the get method. And then it hands in, so what do we need here? So if you look at the get method, it tells you have a self, instance, and class. So it puts in, since we call it on the instance, so we don't have to put the self, but we put the instance, which is our S here, and the class, which we get again with type. So yeah, so this just gives you the same thing. So if you don't want to do with a type, you can also do it with a class. You can do strange dot. That's the same thing. So a little bit less verbose. So that's what happens here. Dot underscore underscore get underscore underscore, and now you put in the class. So of course the type is just giving you the class, and this should do the same thing. So that's what's happened underneath. So usually you never do this. It's just to explain how Python works and how it looks up this descriptor. So that's what happens here, and that's how it accesses these things. You can also access this one directly through the class. So because it's in the class, you can say attribute, and then you have the same effect. You can access this through the class. This would be equivalent to what I just typed here, though. This line is equivalent to this line, and this line is to this line. So 27 and 30 are together, and 31 and 32 are the same thing behind the scene. Okay, this is a dictionary, and this dictionary is read-only. If you look inside this dictionary in strange dictionary, it's a proxy, so you can only look inside, but you cannot assign. So if you like to assign anything, like you would do in a normal dictionary, if you look at X, of course it's not there, key arrow, but you cannot do something like this. It doesn't work. It doesn't let you assign because it's a proxy. It does not support item assignment. So you cannot just set it from outside. Okay, that's how we get to our descriptor. And we can also assign to our descriptor. So since we have this data descriptor, now we just worked with get, but we can also work with the set method. And see, and I wrote a pretty strange set method. I first tried to uppercase my value. If this doesn't work, so if this doesn't have an upper method, I just keep the normal value. So just as example, so I can use my S and try to set things. I set my attribute, and I can set it to a number, and then you see it's setting it, and if I retrieve it now, it's a number. If I set it to a string, then it uppercases a string because it recognized. So that might give you a feeling what you can do. Now you can really, when somebody assigns something to this attribute, you can program whatever you like, what's happening there. So that's a main thing. So very often these descriptors are used in something like object relational mappers or so. So where you have this, you work with a class in Python, but behind the scene there's a table in a database or something like this. If you have something, if you need to kind of bridge this difference between what you're doing in Python and what's happening somewhere else, then descriptors might be an good approach, because when you access something, you can just give the user the feeling it just accesses an attribute or sets an attribute. In the background, you can do things. And that's what descriptors are doing. And typically, it's recommended not to do too much. Not like if you work interactively and you set something, you don't expect it to be away for 2 minutes till it comes back. They think it's broken. Though that's something. It should be something that's reasonably fast if it might be used interactively. Otherwise, people think it's broken. It hangs or something. So you don't want to have this take too long. So let's look at the dictionary of the instance. Now I work with the instance. The instance has also a dictionary. The dictionary of an instance. So so far we looked at the dictionary of the class. And if I set something now to a different attribute, not to attributes, but to something new, then this is just a normal attribute. It looks not different here, but if I look in the dictionary, then I see now it's saved in the instance dictionary. So this 14 is now saved in the instance dictionary, where our attribute goes going to the descriptor. That's a different thing, because our class looks like this. Only this attribute is a data descriptor, and everything else we do is just normal. So this one, since we write this in here, it changes how our instance behaves when we use Azure. But when we use a different or normal name, it's just there's no difference. It just behaves like before. And the thing is, everything is stored in dictionaries, and there's a dict on the instance and a dict on the class. And typically Python, if you look, say s.attribute, then it looks in the instance dictionary first. If it finds it there, it's fine. If not, it goes to the class, and then it goes up the inheritance tree. That's usually how Python is looking up attributes. And then if you define this data descriptor there, then it will execute what's in the data descriptor, what you have there. Good. So now if you look inside, you can see how it looks like. If you look at deer, then you see everything that's in there. You see in here it looks like all this double underscore ones are not so interesting now, but you see this attribute in new looks the same from the user perspective, from the instance here. You don't really see the difference. You don't see that's a data descriptor here. Would you just work with it as it would be a normal instance attribute, but in the background things are going on and things are a bit different, and you can do whatever you like. Good. So strange, if you look at strange, so strange has an attribute which is stored there, we saw already, but strange doesn't have this new. So that's in the instance, not in the class. Therefore, it's different here. And when we access it, you won't get it there. It's only in the instance because we got there earlier. So the last one we have is the delete. So if you would like to delete things, you cannot delete this attribute, because that's what we programmed up here. We say you cannot delete. Otherwise, you can do something when you delete it. So, like if it represents some kind of data somewhere, you can remove a line from a database or delete a file or whatever you like. When you say delete, that would be possible to do something like this. But here we just turn it off, and we say we don't like to delete it. Okay, this is called the data descriptor, which has all the get and the set and the delete. If you only have a get, it's called a non-data descriptor, and they're a bit different. So these ones, we just looked at it, how this works, and now we make a non-data descriptor. So again, we have to do a class. It inherits from object, and then we have our init, self, only self, so I didn't set anything here, just say self value. I just use this example. Self value equals 0, and I'm not done yet. Then I have only a get. That's a difference. So if you don't have the set and delete, then it's called a non-data descriptor. But this one works the same. So you have here the instance, and you get the class. So if you want to, you have access to the class. And now you can print something out to see that this happens, and then just return the value plus 10 for some reason. So just to see, that would be a non-data descriptor. And a non-data descriptor, it's a bit different because you can do a few different things. So I have this class called add10 now, and inherits from object, and I set my attribute again, which is my non-data descriptor, and it just the same procedure. So the procedure is the same, only that I'm missing the set and the delete here. And now I make my instance. And then if you look at the attribute here, then I have this 10 attribute. And that's a non-data descriptor, and now I'm just doing something. But since we didn't override the set. Let's look at the dictionary of this thing, as we did before. Look at the dictionary, and it looks like this. It's empty, it's nothing in there. But now I can say 10 dot attribute equals 20, and then if I look at this attribute, it's 20, and if I look at the dictionary, now this thing is stored in the dictionary, and you see the 20 is stored here. Because I didn't define the set, then I can, as soon as I set it, I just kind of turn off the effect of this descriptor. Because now this is a normal, just a normal attribute in the instance here, and Python finds it first and never comes to the non-data descriptor. So if you want this effect, if you want people to give the this possibility to set it, and now you won't get to the data descriptor from the instance as we did before, because this attribute 20 here will be the first. Our attribute is still there, but in the class, and you won't get there. So that's a difference between the data descriptor and non-data descriptor, and therefore you won't get the 10. Okay. A few things about two special methods. There are two special methods. One is called get, and one is called get attribute. So the first one, the get, when you define a get, this method will be called if you access an attribute that does not exist. So if you have a class and you access an attribute that does not exist, then Python will call this get method, and then you can do whatever you like. So if you're familiar with this, is a very nice way to delegate things. So if you have a class, you can write a wrapper and you define a get, and if somebody calls the method, you can check if the class you wrap has an attribute and just call it from there, otherwise you might raise an exception. Get attribute is different. Get attribute will always be called if you access an attribute, and you have to be very careful. If you use self dot in get attribute, you will get a recursion, because self dot will call get attribute again, and then it will get attribute again, and self dot, and so on, and you get a recursion, and you won't get out of it. So get attribute is a very strong thing, and get attribute actually can be used to override this data descriptor, and let's do this here. So I just define class overridden here, and inherit from object, and I set my attribute and have my data descriptor here, and now I define this get attribute method, and this is very strong because it always comes first, it's always used first, and this one takes a name, and I just say print no way. Okay. And now, if I make an instance here, instance of this one, and since if I wouldn't have this get attribute, then my normal data descriptor should kick in, as we saw before. But if I do this now, then this this one prints no way. And now I have effect. That's probably an artifact of IPython notebook. I'm not sure. It's doing something with my objects. So I haven't tried it there. Because it's supposed to be only once, because I don't access any attribute, but obviously IPython is doing something. And though we have an artifact, so it should be only once. All the other repeats are. So I'm lucky that I don't get into this recursion thing even further. Yeah, so that's, but you see, get attribute is very strong because it intercepts everything, even the data descriptors. So you have to be very careful if you use this. You have to really know what you're doing, and you might get some strange effect because you're used to just say something dot. As soon as you use a dot, you might trigger the get attribute again, and then you get this kind of recursion thing going on. Good. That's something about this data descriptors or non-data descriptors. We will see some examples what you can do with it. And first, I would like to show you some other example where descriptors are at work. So it's nothing actually you're going to use for programming, but you can see where descriptors are all over the place. Because actually functions are non-data descriptors. So if you work with functions, and then you have non-data descriptors. So if I define a function here, and I don't do anything, just the function is there, and then I can say function dot get, and you see this is it has this get because we have this a non-data descriptor, and then this gives you this method wrapper, and this one can be used. So if I have a class which inherits from object, and I use this function inside, so I call a function here, not method, and because actually methods are just functions that happen to be inside a class, and I don't do anything, and now I can make an instance of a, let's call it lowercase a here to make it a bit different, instance of a, and then if I can access this one, and now you see it's a bound method. In Python 2 I have this bound method because it's bound now. If I do the same thing through the class, it's an unbound method. So we have this unbound method, and therefore to get this bounding here, to get this bound method, you use Python is using actually this non-data descriptor thing. To find this to do this binding. So to get the bound method, Python is going to get, and you get this wrapper, what we see here, the method wrapper, and then Python is doing the binding, and then Python knows that this function, it's a method that belongs to this instance. And you can see if you check type here, a type of a function, it's an instance method, and type of a function is also instance method, but it's a different thing. It's bound here. First, if you want to call this here, you have to always supply the instance as a first argument to make it work, because it's a self. You have to explicitly put in self. If you use it through the instance here, you don't have to call it. So I can say a dot func. It works here. But if I use it to the class, I have to supply this little a here, this lowercase a here, otherwise it doesn't work. It gives me an exception because it's unbound, because I have to tell that's a self. And Python uses this non-data descriptor actually to get this method wrapper here, to find this binding here. The method wrapper get returns this thing, and that's how Python goes through and finds this this class. So actually, every time you use classes and instances, you use non-data descriptors. So this is something you don't need to care too much about it. It's just to see that they are used in Python a lot of places. Yeah. So it doesn't have a big effect on your daily work, because Python just works and is doing the thing. But in the background, the descriptors are working. Good. Let's have a look at some examples. I have a few examples, and we will want to look at them. So, because there are a few things you need to be aware when you work with those descriptors. Okay, you see now this from future import print function, so I use a print function, so this file should work with Python 2 and Python 3 the same. And I use a descriptor and I call it class storage, because per default you store everything in the class. That's what you did so far. And I write this descriptor, which is a data descriptor, which is a get and set here, the same thing as we did before. And now I make several instances. You see, I make a class and I use my descriptor. It's the same thing we did before. And now I make make 2 instances, and then I work with these instances, and then I change things, and then I look what those instances do. So I set the value as default, which is none if I don't supply, but I supply a 10, and then you see both of them will have a 10, and I change it, and both of them change back. Yeah, you see, I just assign to store 1, I assign 100, and store 2 also gets 100. Because the way I set it up, everything's stored in the class. So this is something you might want, or maybe you might not want to work, but if you write a descriptor like this, then you set the default value, and then you return this value here, and if somebody else sets it here, it sets the value, and everything will be stored in the class, because everything is stored in attribute, which is the class attribute here. It's in here, and then all the instances will see the same value. That's when you set it up like this. If you don't want this, then you can use a data descriptor that has a instance storage. Okay, let's look at this. Instance storage. So if you want every instance to have its own data, then you can do something like this. That's just an example. So I use UUID just to generate a unique ID. And then I do a few other things. I use a hidden name here and create a hidden name so nobody is supposed to get from there. I also use 2 underscores so you cannot get there from outside. And that's the default. And then here, when I use get, you see I get the instance, and I work with the instance, and I say get attribute instance hidden name. So I get from the instance what's stored in the hidden name, and if it's not there, I get the default. So the get attribute works just like a get in a dictionary. I look up. This is the same. So if let's say this is an instance is A, so get attribute would be the same thing as looking for attribute. Yeah, this one would be the same as saying get attr A, and now then the attribute as a string. Yeah. So, and then I can have a default, whatever you want, you can have a default value. So if it's not found, it will use the default value, whatever you return there. It doesn't have to be known the name, just something. Yeah. So it's like the get in the dictionary, and that's what I'm doing here. I go to the instance, and I use my hidden name that's not supposed to be seen from anywhere else, and return what's in there. And if it doesn't have the hidden name, I return the default. And if somebody sets it, I just set it to this hidden name, which I created here. Okay, and if I do this, I do the same thing as before. I make a class, which I use a descriptor, and I make 2 instances, and then when I execute this, then you see now store 1 changed to 100, but store 2 didn't, because I stored an instance. Yeah? Because you have access to the instance here, that's the instance, that's the store 1 and store 2 in my case, and I can do something with them, and I have a new hidden name for all of them, and then we will see what happens here. So if you want to, you can print the hidden name. It's pretty long, I guess, to see what's happening here. So if I get it, you see, do you have this hidden name at this place, which I created. So this is not supposed to be used from outside. And then I have this storage with this hidden name. And actually, this is now, if you look inside the store 1. Store 1, and you look inside the dictionary of this, then you will see this hidden name. You see that's a hidden name, and then you store this 1 in this dictionary, and you will access this dictionary. That's what happens. Yeah, it's just this. It's just maybe a little bit over-engineered to make it so long, but the easiest thing to do this. So you have this hidden name, and this hidden name actually is used because I say here, when I set it, I say set hidden name, and I will put it into the dictionary of store 1 and store 2. So even it's the same name, but 2 different instances. Every instance can have a different name. Does it make sense? Some people shaking their heads. Okay, so that's what I did. So you can store things in instances, because by default, if you work like this up here, everything is stored in the class. You have to be aware of this if you do this. Otherwise, you might get some strange effects. But you can still store things in. And this is one approach doing it. Just generate some name nobody's going to guess, and it will be accessed by accident from outside. It has 2 underscores anyway, so you won't get there from outside, but also if you're in the class, you will never guess this name, I think. Good. I have a few use cases to see what you can do with the descriptors. The first use case is attribute checking. Checked. Yeah, that's called checked. That's a name. So you can use it for a few things, and attribute checking would be one of them. So if you need to do this, you might use a descriptor. And you see, I have this descriptor, and this descriptor checks for a user-supplied function. User-supplied function to check for type. So this can be useful if you have to work with outside systems where you really need to enforce types. Databases, you want to have the right type for the right column, or other things. Then sometimes you need to do this. And if you find yourself writing the same code repeatedly somehow, then the descriptor might be some solution. And I do the same thing as before. I use this hidden name thing because I will enter my instance storage. And here I supply an outside checker, which is optional. So I set it to none. So if there's a checker, I will apply to this checker the default. Now this checker is the responsibility of the user later. We'll see that has to be a function. And I set the checker and the default. And then when I get it, I don't do anything special, it's the same thing as before. But when I set it, if there's a checker, then I check the value that this value fulfills some certain criteria, whatever I would like to with a checker. Yeah, and I can do something with it. So this would be this descriptor, and then this is something the user is going to write, and this is just an example. I write a function is int and get the value, and I just make sure that my function is the instance of int. So that my value is the instance of int. So it would work with true and false in this case because I inherit from int, for instance. And if not, I raise a value error. Okay, and then now I need to use it, and you see now I make a new class which uses this checked, which is this up here, my descriptor. I use my checked, and here I'd supply this is int function and default to 10. And then I try to default to 12.5, which is not going to work because I check for an integer. And so now it's going to work here because I don't have a checker, but it doesn't work here because I want the integer. So I have this one, and this one I put in the try except clause because here I also have 12.5, but I have this checking function that checks that has to be an integer. And therefore I give an error message and say this would be possible because 12 would be possible, not 12.5. So, and the same thing, then I make an instance here, and then I assign, I just print out the attribute and I assign 100, and these are changes. And if I try to assign a floating point, I cannot do it. I have to use an integer. Yeah. So this is would be an application. So you see, you get this message. Now I really restrict the type of this attribute to be an integer when I define this checker. That is pretty general. So you can define your own method, own function that checks for something else. It doesn't necessarily have to be a type. It can be something else. You can also say it has to be between 0 and 100, or whatever you like, and then nobody can set anything else that's bigger or smaller than this value, for instance. Yeah, and if that's also, since it defaults to none, so if you don't supply anything, it's just a normal descriptor and doesn't change anything. So you can turn this off if you like to. And also you can set a default value here at this place if you wanted to. So you could here at this place have a default value, or just if you don't have one, it's none. That also would make sense. So that's something you can do with the descriptors, and if you access this from outside, then this object would react, and you don't have to write checking code from outside. The object knows itself what it can do and what it cannot do. Good. We are right on time. I'm through with the handout because now we have some exercises, and I think I want to make the exercise an essential part of the whole thing. Do you have any questions so far? Anything that's unclear? So no questions means you have to do exercises, and probably if you do exercises, there will be some more questions. Typically they come up because now you try to apply what I just explained to some exercises. Always sounds easy if you listen the same to me. If I listen to something sounds so clear and I try myself, it doesn't really work. So please do the exercises on page 16. I do have solutions, and you will get the solutions after the tutorial. I will upload the solutions, and I will give you the links. You can download them, but not now. So we have I planned about half an hour, which is quite right for exercises. And then we have a break, and then we go to meta classes. So I will be here, so you can ask me questions. And if the questions are interesting for everybody, I will answer them for everybody. Okay, please on page 16 do the exercises, and we'll see if everything works out. Yeah. Yeah, just take mine for now. Oh, yeah. There should be pretty much for every seat there should be a handout. Everybody downloaded the things. I can upload the rest also. So in the meantime, I just upload the other missing examples. Yeah, just a minute. I put something else in there a few minutes, and then you can download with everything together. Just take mine. I have a spare one. Yeah, you can ask Stuart. It's off. Yes, and so I updated the downloads. If you download again, also if you don't want the types as long URL, have a shortened URL. So if you maybe I just make it bigger so you can see it's a shortened URL. Browser's updating. So otherwise this would be, I just put in 2 lines, the other one. 2 are the same, whatever you prefer. A few people had some issues with downloading. It seems like this additional directory was not in there, some cache somewhere. So if you cannot get this property directory, I changed the name of the file, and then it's inside. I didn't do anything, I just changed the name. And so if you see problems, so maybe there are some maybe here they are caching the files here, I don't know, somewhere, something there. So just do this one. Good. Who has solutions? Solutions? Okay, so I'll show you a few things what I have, and maybe, okay, just put it in strings. So I have solutions for the 4 exercises. Let's have a look at them. Exercise 1. So that's what I have here. A descriptor that allows only positive values. This one is still with a class, so it's okay. So I set value to 0, and here and then when you have set, I'm just doing some checking that the value is correct. And here I decided to use abs value. If you check a is less than 0, if you work with Python 2, it still works because Python 2 still you can compare strings with numbers. In Python 3 you cannot anymore, which is nice. But in Python 2, therefore I used abs because abs only works for numbers typically, and then you would get a different exception if you try to convert so absolute value of a string doesn't work. And then that's the only check I have in there. Oops. And then I use it here, and I have this value which is positive only, and I set it. Knowing this is, again, it's per default it's class storage, so everything's stored in the class under the instance, so I have to be aware of this one. But now if I try to set a negative number or set an x, I will get an exception here and there. Do you have similar solutions? Something like this, but and again, there can be tricks if you just check that things are less than 0 or so. It might not be because you want to have a number. It doesn't really make sense to check a string being less than 0. But this would be something you can do. So extended to do rounding things, for instance, exercise 2. So they have the same thing. Now when I go into the get and I round to 2 digits here. So then everything else is the same. I just, to make it easier to understand, I just copy the whole thing, and then the only thing different is here, use a round method and go into the get round function to round the value to 2 digits. And then when I do this here and I call my test function, which yeah. So since I imported print function and I've forgotten to do this here, I get invalid syntax. Why do I still get? Yeah, some places. Yeah, so because I loaded other files that have the from future import print function, this will be valid for my whole notebook, and though this print I've obviously forgotten to change this parentheses. And then now everything is rounded to the digits here, and this is something you could also do some checks in there, something like this, and then you return it in a different way, rounding, if this is what you want. So prevent the deletion is pretty easy. So you can just exercise 3. You can just now at this place here write delete and you just print something. You could also raise an exception if you like to. So if you really wanted, you can raise an exception. This is kind of just to demonstrate how it's going, because if somebody's running it, just would print it, keep going, which is might not be a good idea. So maybe raise an exception might be better here. And just this is doing delete, and if somebody wants to delete it, then at this place you will get the error message again. I forgot the parentheses. I need to add them to make it work with Python 3. And then I get another one I forgot up here. Yeah. Yeah. One more. Yeah. Okay, now it works, and then you get this don't like to be deleted right there. Okay, the other one might be a bit more interesting. It's about the price with value added tax. So since I'm from Europe, so we have this value added tax thing there, and it's different in every country. And then that's what I did here, value added tax. And then you set it to the rate, which is, well, I come from Germany, that's our rate. You have to put 19% on everything you sell to end consumer. That's about the cost that goes to the government. And this is the default 19%, but you can also set the other one. And here I have this. Now I do this instance. You see, now I go to the instance and get the net price from the instance, and to multiply it by a rate and round to 2. In reality, if you work with money, you wouldn't work with float. You use decimal. Yeah. But just for this, for the purpose of demonstration, what you can do, I do this rounding. Of course, there will be. If you do the rounding all the time, there will be quite a few errors later on if you sum something up. But as an example. And then now I use a set and I erase a not implemented error. You cannot change this one. So now you can do a price, and then you have this price total. And if I don't do anything, I get the 19%. But like in Denmark, they have 25%, so you can do 25%. Yeah, here, 1.25, or a different country, different rate. And then you can do this, and now I have a price of 110. And if it's Germany, and if I print the total price, this will do the conversion in the background for you and multiply by the rate. And here makes sense to have one rate per class, because this rate is the same in the whole country. For every price, it's 90%. It's more difficult, there are different rates, but just assume we have one fixed rate, then it makes sense to store this rate per class, and then have but the price itself is per instance. So every instance can have a different. This 110 is for every instance a different one, if you want a different number. But the rate is the same for every country, and then you cannot set it here in this place. And of course, I have to put the parentheses here to make it work. But this is maybe something a bit more practical. You can see what you can do with it, and it makes it maybe more comfortable than solve it in a different way. So you see, you get a not implemented error. You cannot change the value, and Germany has 19% and Denmark 25%. It's a bit more expensive there. Same thing. So that's maybe an example. This is a pretty long traceback here, which I get when I try to set things. Yeah. Yeah. So that's a new bit.ly URL. So bit.ly 10MEZGL. Hope it's big enough. Any more questions? Good, it's break time. So we have 20 minutes break. And we start back again at 10 to the hour for another 1.5 hour till lunch, which is 12:20 if I'm not mistaken. So we have another 1.5 hours for our meta classes. So there should be hopefully some refreshments outside, something for the break. So you get some drink, maybe something to eat, I'm not sure. So let's meet here 10 to the hour, which is 11. Yeah. You can check if there's one. I mean outlets. I'm no. Ask the people in the back. They should know the technical. Yeah. Okay. I just realized that there are some problems with download. Okay. Control F5 bypasses. There's a caching in the network. It's one thing. That's why we didn't have a problem with updating. And the other thing is somehow only Macs get the zip file as a zip file, and the other operating systems get the zip file as text. I wasn't aware of it because I use the same system for years. That must be the network because I always worked. So it's yeah, the wget works. If you have wget, if you have Windows and don't have, you can install wget on Windows. Sorry, maybe you can fix this later. I have no idea how to do this because it always worked on Windows machines downloading. There must be something with the network I'm not aware of. I didn't anticipate anything like this. Okay, but let's continue with metaclasses. So I'm gonna open a new notebook. You see the notebooks are very nice, but they cannot be too big. I make a new notebook and I call this metaclasses. So, and now I've forgotten how to change this to the shortcut here. To do this. H1, something like this. Good. Metaclasses, the saying is, if you don't know about the metaclasses, then you're not going to need it. So we don't want to stop the course right here. We want to keep going for another half an hour. Metaclasses is maybe at least a topic that has some kind of feeling that's very complicated, very difficult. Metaclasses are something you don't use every day in your programming. They're out there, they're used, and they can be useful. And nowadays, if you have class decorators and things like this, a lot of things can be done without metaclasses. But still, it can't hurt to know a bit about metaclasses. And I will show you some applications that are actually useful, that you can use to kind of inspect your own code, rather than writing production code with metaclasses. That's something that might be interesting. So actually, a metaclass is pretty easy. Metaclass has the same relation to a class as a class to an instance. So that's why it's called metaclass. And it sounds easy, but we want to look at how this works. So in Python 2, you have this new style classes. So when you inherit from object, then you get, I have to make it small, otherwise it's jumping back and forth all the time here. You get an if you look at the type, you get a new style class. That's a new style class. If you do this without, this works only in Python 2, it doesn't work in Python 3. And you don't inherit from object and you look at the type, then you get this class object thing, which is an old style class. So you should never use old style classes because everything you looked at descriptors and everything about metaclasses doesn't work. So you can sometimes they still do the trick, but it's better just use inherit from object so you won't have problems. You never know what they're going to do later on with your source code, and then you would need to change things. So but you can also say, okay, I have my class C, and I don't inherit from object, but I set the meta class. If you do this in Python 2, you say meta class. So you use this attribute with 2 underscores. So this double underscores in front and the end always mean it's something special in Python, and you should never invent those names yourself. They're always reserved in Python for that things, and there might be some new names coming up later. And here I assign type to it. And this now, if you look at the type of this C, it's also type. So this would be, instead of inheriting from object, which I did here, you just can set the meta class explicitly. You rarely do this. Inheriting from object is it's nicer. In Python 3, if you want to set a meta class, you cannot do this anymore. The syntax changed. So in Python 3, you will have to do. I can do Python 3. So I can do Python 3 in the browser. And if I try to do something like this, here I have to put print in to make it work. Of course, this and this gives me a syntax error. Python 3 first, and then why is Python 3 not found? Double, thank you. Okay, and it works. Where's my point? Because in Python 3 you have to the new syntax, as far as I know, I'm not sure why this works here. You have to say something like this. To try this out. So this would be something you would do in Python 3. Meta class. Yeah. So I'm not sure it's Python 3.4, but I'm not aware that they changed anything. There's no changes between 3.3. But this is a new syntax for Python 3. I'm not sure why the old syntax works. I'm a little bit surprised myself because that's a new syntax. If you have Python 3, you have to do this, because I always tried and you always have to change it. There are some libraries that do like a with meta class, kind of a little bit of hack that make it work for both, but that's a way to do it in Python 3. Okay, this is this meta class. We supply here, and type actually is a meta class, as you can see, because I assigned the meta class here. And now let's slowly go into those meta class things. So A was my new style class. Remember, type of A was my new style class, this type. And now I can look inside type A and look at the base classes. The base classes come in a tuple. That's a tuple, and since we inherit only from object, it's a tuple with one element. So typically in Python, a tuple with one element has a trailing comma. The comma is very important, otherwise this parentheses wouldn't do anything. It just would group object with object, and it wouldn't be a tuple. That's why you have this. Though this one, you inherit from object, and because object itself has a meta class types, therefore also A gets a meta class type if you do this. This is just to have this old style class and new style class thing is just for backwards compatibility in Python. Because you still want to have those old programs that don't use new style classes working, and you want to have the new ones at the same time. That's why if they are object in Python 3 is not necessary anymore. But setting using the inheritance from object helps to set the meta class. The other thing is in Python 3, if you set meta class somewhere, so if I look in globals gives me my global namespace, which is pretty big. So since we are an IPython notebook, this is a bit big. So if you look at this, it's a few hundred. No, I want to have lengths. That's not too big actually. The length is not too big. That's all global variables that are defined here, and I missed. I want too many. Yeah. Get length. Other way around. Sorry. Yeah. That's what I want. And 46. So, but if you look in globals, then there's no attribute called. It's a dictionary, and there's no attribute called meta class. But you can set it in globals or put it in the very first thing in your file. And when you do this, it's not in there. Meta class, even if you type it right, it's not in there. And then you can just set this meta class. So I use meta class right here. Just copy it, and set it to type. And then every class that doesn't has its own meta class will get this one. So now if I make class D, which doesn't inherit from object, and I don't set a meta class, the other two methods. And now if I say type D, it's type, not class object anymore, because I set it in global. And everything I do in my notebook will have. But that's one thing. So if I have a bunch of old style classes, the first line in the file, you say meta class is type, then you get new style classes all over the place. That would be one way of doing it, or just put object in. If they don't have the many classes, it makes sense to put 3-4 objects in there. You still have the, if you wanted this old style class, there's this types library, import types, and this types library has a lot of types here. Types, the class type is here. So you see this is an old style class. If you want to work with them, you have them in the types module. Good. So let's look how actually a class is constructed. So if I define a class, as I did C, inherit from object, just to make it right, and I just set an attribute to the class. This is a normal way you do it in Python, but exactly the same thing would happen if you say, or happens if you say type. Actually, it's the same thing. I use C to use the same name of this object as say type, and now I can make a new class. And I use the name, capital C, and now I just put the same information in there. So I put a tuple of the base classes, in this case object, and I put a dictionary with a namespace. So it's just very easy, just put a dictionary with a namespace, something whatever you want to define a dictionary, something like this would do. And now this is exactly the same. So those two cells, this one, these two lines, and this line is exactly the same. So you see, you can create classes dynamically if you like. You could write a loop over all the letters of the alphabet and create a class for each of them. If you wanted to, without actually generating code and executing the code, you can just use type. You should not. I think you should not do it unless you have a really good reason to do it. But it's possible, and it shows you how Python actually works and how a class is created. You can always do it like this, and you can do even more. Now I could define methods on the fly. Yeah, I just define some methods on the fly. Something like this. This would be the first method, and I can define another method on the fly. So the self wouldn't be needed here, but just to show you what you can do. Return A plus B. And now I can add this method. Now they are just not methods, they are just functions that happen to be defined. And now I can use the same line, and just in this dictionary, I just also add my two functions here. And of course, you should use the same names here. Init is init. Actually, I can break this here. Init is init, and add is add. So this is no magic. You can do this, and then you can assemble your class step by step. If this needs to be done like this, no string. So if you do something like this, it should work, and you get your class. This must be a colon. You get your class C, and now if you look at C, then you see it has an add and an X in addition to the meta resolution order thing. So now this is the same thing as writing the whole thing out. You can construct your class on the fly, which might be useful if you read some data from a file or from a database and you want to construct classes according to this data somehow. But the problem is if you generate them, you also have to be able to use them. Yeah. So it might be easier to use dictionaries or something in the first place, but sometimes it might make sense to generate classes on the fly. This is not very difficult. Okay, so we haven't really looked at metaclasses. Let's make the jump to metaclasses. So you can define a new metaclass by actually defining a class, but now don't use object, use type. That's it. Now we have a new metaclass, and now to do something special, you have to change something, and we just override stir. This is a string. If you convert something to a string, then Python will call this special method and returns string of something. And I just want to override this one. And now don't use self, use CLS class. Technically, it wouldn't matter how you call it, but just to stay sane, use CLS, not self, because now it's not an instance, it's a class you get. Remember? Metaclasses are to classes, but classes are to instances. So the self becomes a class. That's it. So it's not very difficult. It's just you have to make this jump now that we have this. Now have this metaclass. Now a return and just say something. With name, and I can just add the name, just class name, for instance. Put a space here. Though the class comes with a name, a lot of objects in Python have this underscore, underscore, name, underscore, underscore, and the class itself also. And now, if you have this, and now I use this meta class in my class X, for instance, and I say meta class is my new meta. And if I do this, and now if I print or convert it to str, then X, then you see I get this one. Instead of the normal thing, if I would have my normal class A from before, I would get something like this. And now I overrode str, and therefore get something like this. So I changed the behavior. That's something you can do. And every class that has this meta class, so everything would inherit from X, would also get this new meta class, for instance. So very often you actually don't use a meta class like this. Very often you make one base class and just inherit from the base class to get the new meta class. That's pretty common. So then you have to don't mess around with meta class. And depends on the user. You don't have to tell the user that they're using new different meta classes. You just say you have to inherit from this class. So inheritance, most people know about inheritance. Fewer people know about meta classes, so you don't need to tell them about meta classes. Just let them inherit from X, and they will get a new meta class also. And yeah, that's what we have. Good. Typically, what you do with a meta class, you override something when you create a new class. That's the most common case. So you want to do something special when you create a new class. And there are two ways to do this. The first way is overriding new and overriding init. So init we saw already. New is also classes have new. You rarely use new because you don't need new. So if you use init, you always get the self already there with a class. If you use new, you actually return a new object. You created an object. Init never returns anything. You always has to return the new class. And the same thing applies here for meta classes. You also have a new and an init. In most cases, the init is enough to get what you want to do. I only found one example when you work with slots. Then you have to have new. Okay, there's a lot of theory. Let's look how this works in practice. So I define a new meta class, and I inherit from type, which makes it a meta class. And now I override this new. That's a stronger one, this new. And this has a special signature here. So you have to have the meta class. You have a name of the class. You have the tuple of the basis. And you have a class dictionary, which is a namespace. So that's what you get. And then I just print all these out, just to see what they are. I just print them all out. So it's Python 2, just don't use it, parentheses, MCL. Though you just want to see what's coming, makes sense just to put some prints in here. So print basis is a tuple, as we saw before with this object. It's the same thing here. And last one is a dictionary with my class dictionary. So just don't call it dict is a built-in function, so use some different name. So that's what I have here. And now I defined my new meta class. Now let's see if I use my meta class, then you will see when it happens. This is interesting. Now I make a new class. And I use this new meta class thing. And now, see, it happens when I define the class. So not when I make an instance, but when I define the class. Obviously, this new, it's doing something. And you see here, you get this meta class, which is meta because it comes through here, my meta. The class name is here, comes from there. There's no basis because I don't inherit from anything. Yeah, and then I get the dictionary. I mean, the dictionary has a few things in there that are always there, like a module name, a main, meta class, those things. Depending where you define the class, you might get something more even. But you know the module name here, which is main, because I'm in this IPython notebook, which is like the main file, and the meta class name. That's what Python populates in there, so you can access this meta class from here also. So that's what the new is doing. So it's actually creating, and I've forgotten something very important. Sorry, you always have to return, though. That's very important. You have to return, and you have to return the new, because now it's doing something, but it wouldn't work my class because I forgot the return. So we have to return, and I use the super. So it's Python 3, Python 2. You still have to put in the meta and the class, but it's the same thing. So I get the parent, which is type in this case, and I get the parent, and you see now this meta class is used like self here in the new. Not really, sorry, because it's new. If you do this with a class in Python, this is not self. This is a class, but here's a meta class. But now I use super here to get my super class, and I have to call this new on type actually. Otherwise, I won't get none back, yeah, and it wouldn't work. And I have to use this with the same signature I used up there, name, basis, and this class dict. Yeah, so you don't see any difference. But now, if I make an instance, it's going to work. Otherwise, I wouldn't get a valid class out there. Yeah, so you have to use this super, and this is the looks very similar what you would do when you use new with a class, but with a meta class, this one is not the class; it's a meta class argument. So this new you don't need very often. Most of the time, you will get away using init. So let's do this. Let's look at init. Init is a bit different because if you use init, will be called after new, and the class already exists. So the first argument is not the meta class, but the class, which is different. So it's like now it's like the self. So you have this self here, and the rest is the same. You get everything. You get this new. Now the init get those things, but there's no return. Init never has a return. It's the same thing. There's a lot of things that are very, very similar between classes and meta classes. Only that you have the signature here with a class name basis that has to be there. Otherwise, it wouldn't work. And now I don't return anything, but I still use super, no return. But I still have to initialize things, so I use the same thing, my meta. Here, now I use class, not. And I call the init of, and now there's no name basis cdict. Yeah, the signature is a bit different here because there's no self. The class doesn't go in here because it's here, whereas here I put the meta class in. It's a bit different. That's but it's the same difference applies to classes. Okay, so that's something you can take as a recipe course. You can change anyway, and now if you can use it as a meta class and work with it. That's actually all about the theory, but now I want to show some practical things to make sense out of it, why we do all those things. And I have a few of those use cases, and hopefully those use cases will also serve as some explanation how things work and why they work as they are. Okay, let's load. No, I have to go in the directory first. So the directory metaclasses, I have a bunch of those things. The first one is no class attribute. Yeah. So, and now I use the meta class to do something, kind of magic with my whole source code. And now I would like, for some reason, create classes that have only methods and no attributes that are not callable. So everything that's an attribute in my class has to be a method, has to be a callable. And this one you can do with a meta class, and you can enforce the things that happen. And what I do here, I override init, which is enough for this purpose, and I do a few things in init, and then this is all I do, and then every class that has this meta class will behave the way it does. That's one of the main advantages of meta classes. You do it once, and you can propagate this behavior to a lot of other classes without doing very little typing work. So it doesn't really matter how many classes, if they all have the meta class. You have to ensure somehow that they get this in a meta class, but then they behave this way. This is very powerful, yeah? But you know, with power comes great responsibility, because you change the behavior of Python. The meta classes is something you should at least think twice if you're going to use them or not, because you change how Python behaves, and this might surprise your users. And your users, you might be yourself later on, do something that behaves differently than you expect. So it's very nice to experiment to get to know how Python works, but if you want to use it in production, you should be very careful if you really need meta classes. There might be other ways that are not as intrusive as meta classes, like class attributes, class decorators or something that you can get similar effects here and there. But let's look how it works. Okay, I override init, just the same as we saw. We have class name basis, and I would like to allow these ones. I would like to have module, meta class, and doc, which are non-callable, because Python puts module and meta class in their doc anyway. So you want to have them. But everything else should be methods. And now it's pretty easy to do this, because now I get the cdict. And this dictionary contains all the methods that are defined when somebody types in def method name. All of them go into this dictionary. And then you just go through normal dictionary, items, gives you key and value. And then if this key is not allowed, so if it's not one of those three up here, I use a set, so you don't use a set. It's just for performance with three names. It doesn't really matter, but just to show that I want a set, I use a set here. And then if it's not in here, and it doesn't have this call. And there's also a built-in function callable. It used to be deprecated in Python 3. Now it's back on, so you could use it again. So, but this is the same thing. If you check for attribute call, then everything that's callable. So every function method and classes with this special method that can be called, it's callable. In my case, it's what's a method. Then I give an error message and raise an exception. Say, okay, that's not possible. I don't want this. And I raise an exception. And this way, nobody can ever define a class that has attributes except those three that are not methods if it uses a meta class. You see? That's what I'm doing here. I use this meta class. I use this way to set it. And I define it with a method that's fine, that's going to work. But then I use an example here, and I do something like this. And this is not allowed because A is not callable, and then I'm not able to define it with an exception. So these things work at compile time. The minute you define a class and you import a file, and Python will create this class, you will get an exception. So you will never even get to make an instance, because you're one level earlier you're not able to define this class. But it's pretty strong, because people cannot define a class. You get an exception very early on. And if I execute this, then you see now I have an exception. Here there's an exception that the order's a bit different. First you have to print out hello from attribute less, which is here. This works. And then here I get this exception. It tells me found and callable class attribute A, only methods are allowed. Yeah, so you see, you get the name A because I print this message here, and it's out of my. This key is A. Yeah, so I know the name of the. I can create a nice exception and telling the user, okay, this A is not allowed. I don't want this. So it's just an example. And you can apply the example to many other things in your classes. You can check for a lot of things. And this is something that happens at compile time. And everything that gets this meta class, I will show you some little bit dirty tricks where you can kind of distribute the meta class all over your place. And then you will have these checks in your code. And this can be useful. So this meta class for meta programming makes kind of sense. Yeah, good. That's the first example. Where you can prevent this non-callable methods. Good. So then I was looking for a use case actually where you need new, because most of the time you can get away with init, and init means the class actually is constructed already. But when you use slots, that's not the case, because slots are actually some mechanism in Python to save memory, and once you use slots, you cannot use normal attributes anymore. You have to predefine them as slots, and only these ones are allowed, and this saves the memory. So if you make like millions of instances of a class, then you can save a bit of memory doing this. But otherwise, it's not actually recommended to use slots so much, and typically I don't use them. But this is an example that actually needs the new, and I show you how this works. So I have this slotted type here, and for this one I also use a descriptor, because we just had descriptors. Why not use a descriptor also? And this is just that's the same type descriptor we saw before. So we have this. I supply the same principle actually. I supply a data type I would like to check to have here, and a default value, and I set the data type, and if there's a default value, I use it. Otherwise, I call data type. So data type could be like int or list or something, and you get in 0 if it's int, or an empty list, or anything that's a data type somehow. And then I have my get, which just returns, and set is checking that my value is of this instance of this data type. So if I want to set something, then I check. If I used int here, then the value has to be instance of int. If you use list, it has to be instance of list, and so on. If not, I get an exception with some information about it. Otherwise, I set it. And delete is not allowed. I just overwrite it. And now I use new, because I want to use slots. And slots, if I use init, I will be too late. I cannot interfere with slots anymore because they are set and done. That's why I need to use new. But for most other things, the init is fine. So now I do this new magic. So I use the signature we saw, meta class name basis dictionary, and I create my slots on the fly here. I use a list, and this one I will later on set to slots. So this will be allowed later when you use slots. So I go through the key value of this dictionary I get, and then I check. If it's a type descriptor, I do something, because if this value, it's of this type descriptor I defined up here. So we will see later on how this all fits together. It's a little bit a long prelude here to get there. And then if it's like this, I use the name and use underscore key, set as a name, and then I append this to the list. And when I'm done with all of these, then I append the list of slots to slots. So typically you do this manually, you write out the names, but here I go through, and everything that's a type descriptor here will be added. And then I have to do this super thing and return a new class here. So if you do this in Python 3, you have to use this syntax if you don't use one of those libraries that help you to use like this meta class. So it's a bit different. And then I have this I have this typed, and that's typically how I do it. I use metaclass only here, and then I don't use metaclass in all my classes. I just inherit from typed, which is inheritance is usually easier to explain than using a metaclass, and users don't even have to see the metaclass. You just give them the class typed, which has this metaclass, and you don't have to bother with actually giving the metaclass out, so to speak. You just say, okay, that's typed, inherit from there. Okay, and now I have this this descriptor thing, as we did in the morning. So we have this int in the float. So descriptor here, this is a thing. Yeah, you see, that's a data type, int and float, and this would be the default, which defaults to none here. And then I make instances of my class here, my class, and I print, probably have to put parentheses here, and I print out the attributes that are there, and then I look at the slots, and then if I want to assign something new, that's impossible because I use slots. I can only use those slots, those only attribute 1 and 2 that I defined, and not a new one because slots are closed. You cannot add anything. So let's look at this first. What comes out of here, and then maybe we can add a few. We can add a few prints in there to see what actually happens. So this would be opening. So yeah, see invalid syntax. Yeah, okay, thank you. Yeah, see, now it's not allowed to do this. I get an exception, and this is an exception. So now first I get, let's look what's print out, the 0 and the 5.5, that works. Yeah, that's what I'm printing out here. This is 0 and the 5.5, that's what I said. The 0 is a default, so if I don't do anything, it sets, say, calls int, and int returns a 0. Yeah, you see this? No? Okay, here. I give int, but I don't give a default value. That's why I call here int. And when you call int, you get a 0. Yeah, so int is just nothing special. If you call int, you get a 0. Yeah, like if you call list, you get an empty list. So you call int, you get a 0. So there's a default the constructor. If you don't supply anything here, you get a 0. That's what we do here. And here we have this 5.5, and this works. I get the print out here, the 0 and the 5.5. And you see then here the whole dictionary, and you see the attribute 1 and attribute 2 with these underscores I put in there. And only those two are allowed and nothing else is allowed because I said so. Yeah, because only these two attributes here are in slots, and they are allowed and they are set here in slots, and you cannot set anything else. Yeah, so therefore you can protect it. So it's quite a few concepts coming together because you need to know a bit about slots, but slots is not difficult, just to apply to the list of slots. And these are the attribute names allowed, not anything else. Therefore it saves memory. And then we use this type descriptor to do this thing here. And this one has a meta class, and the meta class uses a new, and during the construction it checks if it's a type constructor, and then it adds those to the slots, and nothing else is allowed. So it has advantage. It's much shorter. You only have to do this here, and you're done. If you want to have the same effect, and you would need to write quite a bit of code in the beginning to check for things and write it manually, makes it shorter, but also a little bit magic. This can be useful if you really need this type protection anyway. So if you work with some outside data, that have to be ints anyway. Yeah, or have to be floats. That's a descriptor thing. And also you want to check, and you want to add slots automatically without repeating this attribute 1 and attribute 2 in the list. It's doing it for you. Every time you make a new inherit from typed again, you don't have to do the slot thing manually. It's doing it for you. That's what metaclasses are good for. If you write it once and you can use it many places, and you would potentially reduce the amount of code you have to type quite a bit, and it's the same thing again, which would be pretty difficult to do it with other methods. It's not really impossible, but would be maybe more cumbersome with other methods. Comes to surprise with a little bit magic. So that's what the slots are doing here. And as I said, this is the only example I could find where you need the new. I'm not aware of anything else so far that would need the new. Everything else you can get away with the init, which what I would recommend using the init here. Good. I have another example that goes into the debugging. I think metaclasses sometimes can be pretty good. Like if you inherit a bigger code base and you want to know what's going on, then metaclasses could be a tool that can help you to kind of inspect what's going on. So this can be, that's what I'm doing here. And actually, I just want to count how many of these classes are defined. That's called Automata Python 2. So I have a Python 2 and a Python 3 version here. That's the Python 2 version. And you see, I'm using a little bit, this is something for debugging. I'm working with built-in, actually put something built-in. That's something I don't recommend typically. For debugging, it's kind of okay. Yeah, because debugging is something you only do yourself, and you're the only user, and then you don't give it to anybody else. If you work with built-ins, that's not considered clean if you add something to built-ins, but what I'm doing here. And then you can turn everything what I do on and off. If you set debug to false, then nothing happens, everything is just like normal. And if you set debug on true, then the whole world changes here. And this is a nice thing, you don't have to go in and change code in many places or sprinkle if statements in your code. You can use this. And if you turn it off, there's no trace whatsoever, nothing changes. Yeah? But if you turn it on, then you have this debug on. And you can keep it inside the code actually, because if its debug is off, well, if they make sure debug is off, then it's just normal code and there's no surprises. So that's what I'm doing here. So only if there's debug, actually I define this class. See, this is my meta class. And here it has all the names and has a counter 0. I use the class variable because I want to count all this what I have here. And init is enough, as I said, at this place. And I want to have all class names and count how many classes are defined. And then I just check if there's a counter already. So if it's not 0, then I just append here, append to this names list up here, and I use just the class name and the name of the module name and the name of the class here, which I get from here. And then I just show them information that something's going on, the counter, and I print the names, and then I use my super init here, and I increment the counter. So I increment this counter. To get this counter, I use debug. This is a meta class. Now I know how many classes actually have this meta class, and I can count actually how many classes are imported in my code. Yeah. So of course you can always use static tools to go through, just grab for a class or something, but you really know how many classes Python it's dragging in. And then I do something. I just replace the built-in meta class with debug meta. So everything here, I make a new object that inherits from object and has a meta class debug. And then I go to built-in object, replace with object, and the type is meta. This is very strong. So I change the behavior. And there might be some side effects if you use some bigger libraries. So far, if it works with Python 2, and now every new style class that inherits from object actually gets this new meta class. Yeah. So this is typically nothing you want to do in production, but for debugging, you get some. If something goes wrong, then it goes wrong. You won't see, but it can be interesting to actually measure something. And now I make two classes here that inherit from object, and one that doesn't inherit from object. It's an old style class. This one wouldn't be counted. I only can reach the ones that inherit from object at this place. And let's see if it works from here. And I import module 1, and I have to look at module 1 first. Load mod 1. Yeah, I probably have to do this from the command line. No, I have to do it from here. Can only import from here. Yeah, so it works from here. We have to look in the editor. Now I have a little bit problem because I put something in, it doesn't work. I cannot just load it here. But you see now it's counting. Now I count that I have two classes. You see debug meta in action works here. So you have this two classes. Look, nothing special. Yeah, but now it's printing this here and just has a counter, and you see how many actually classes are defined at inherit from object at this place. And I see this mod 1 is something that shouldn't be in there. Delete this. I don't know where it comes from. Likely. Of course, there's no mod 1. That's something. Yeah. Something I didn't take out, obviously. I corrected something and didn't take it out. This has to go. Doesn't make any sense here. And now, oh yeah. Obviously, I crashed my kernel. I shouldn't do this in an IPython notebook because now I have some strange effects probably. Because there are some more classes, not only mine, but yeah. So there's some more classes here, and it's repeating this one in here again and again and again. It's probably better to do this from the command line. So I just go to the command line. Meta class, because I'm messing with this built-ins, and IPython's doing a lot of things behind it. That's probably the reason. And now I can say Python. What was the name? Auto meta Python 2, and then you get this when I have to edit this file to get rid of this mod 1 is somehow forgotten there. Yeah, see, if you mess around with the thing in IPython, because IPython is doing a lot of magic itself, so it doesn't really like what I did, and I have to get rid of this import. I don't know where it comes from. Okay, but as you can see, it's counting my two classes, and it doesn't count number 3. And that's a pretty strong thing you can do, but you can like fortify your program with it, and you can see what's happening in there, and you can monitor. The same thing, it works with the Python 3 version. So the Python 3 version looks similar. Looks like this. Yeah, so there's no import mod. So it's the same thing, but only when you have an object. In Python 3, you don't need to have an object, then you won't get it. I haven't found a way to get around it with it. But if you run this with Python 3, then it should work. Python 3. Then has the same effect. Number 3. It works in Python. Oh, that's Python 2.4. Oh yeah, let's see if it's Python 3.3 is a different. No. I'm not sure if I can get Python 3. Just installed Python 3.4. It works the same. It's the same. There's no difference. That would be strange. Okay, you see, you also get it to some degree to work with Python 3 as long as you inherit from object here. You can do this. So that's very strong. That's certainly nothing you want to put into production. But you can think of a few of those applications where you can put things in your code and can find things out of code. Yeah. Yeah, you don't need it right now, but if you, I tried it. If you, there's a few places when you work with instance methods and class methods, then you need to do this. There are a few kinks to it. So I tried it without. It works fine, but some things don't work. So you need to override type also. That up because other classes don't inherit from object, then everything that does inherit from object also would get it from type. Yeah, that's what I wanted with class 3, but that's difficult. Sometimes it didn't work out as I intended. Yeah, yeah. There's a few things, and you might go into some problems if you work with a few other things. It might not always work. So you have to be careful. You have some really complex library that's doing some tricks itself, then it might break. So if they mess around with metaclasses themselves, then there might be something that doesn't work as expected. Good. Yeah. That's some examples how metaclasses work. So it's not that much actually, but it can be pretty involved. So as I said, the typical thing here, the typical thing is to override init or new if you need it. And now we would like to do some exercises, unless you have some questions first. You wanted some exercises, then you can do it yourself and you can see how it works. Because it's pretty theoretic here and there, but if you try to do it yourself, you might find it can be useful. So on page what's the page? Page 27, last page, the 2 exercises. So first you create a metaclass to prevent using names with more than 30 characters for methods of a class. So very similar to what I did with preventing callables. Just now you can check the length of the class name. And the other one is a metaclass that requires a doc strings. So that can be something. So you can check automatically, easily, and actually make the user type a doc string. Otherwise, it doesn't compile. Just as an example what you can do to get the feeling what metaclasses can do and how this works. It's a little bit academic maybe, but it can be interesting if you want to get to know something about your code. So page 27, the exercises. So, who has solutions already? Who solved exercise 1? Yeah. Exercise 2? Few people, so a few more minutes maybe. So most people have at least tried. So how's it going? Who finished number 1? Most people. Who finished number 2? Half. Okay, let's have a look at the solutions. But actually, it's pretty simple. You can just look at what I did, the examples, and just adapt them a little bit. That's a typically good approach to get started. So I have this check. So I just have my own exception here, but then I have this meta class here. You can see type meta class, and I want to check the name. So if the method names are too long, you can do this with PyLit, but you can also just not even allow names that are longer than a certain length. And that's what I'm doing here. You just can adapt this pattern we had with init, and checking for if there are not non-callable methods, what we did. But I did just adapt it a little bit. You can use the same thing. You go through all the names and the values, and then if this is callable, so it's a method, then I should have a docstring, and I just take the length of the name, and if this is too long, I hardwire to 30. Obviously, you can also make it more flexible and just change it somehow. But now I put the 30 in, and then just create a little bit longer message, or say, okay, this name is too long, so I use here the name, back there. You can see it here after the % sign. It's just out of the picture. Yeah, it should be there. Yeah, there it is. Somehow the browser doesn't let me to do this. So the name there, and then give some explanation. And here again, I use the lengths, which I have to calculate twice and show the lengths, and raise an exception. And then I have to use super here, as always, to call the init to get a proper meta class or better class back. So that's pretty much the same what you did. The only do this here, adapt this here, and then you can do check. And I use a meta class here, and this method is fine, and this method is too long, and you won't be able to even define it. And Python will raise an exception at this place because the name is too long. Yeah, so this is something you get an exception. So of course you don't necessarily need to raise an exception. You just can log or just find out where names are too long, where problems are, and of course not only lengths. You could also check for something else. Here you can check for other patterns in the names, and so on. And you can not only check the names of the method, you can also check the name of the class. So you could say, okay, do this only if the class name follows a certain pattern. That would be also possible. So there are a lot of things you can do, which would usually require more work doing it the other way. I don't say there wouldn't be other way, but that's some of the applications you can have. That's exercise 1, and 2 is similar to some degree. Exercise 2. Here I just have this docstring exception and just have a check if it's a special name or not. And I use this regular expression here at this place to make it a little bit smaller, otherwise it doesn't fit on. Yeah, this regular expression. So this is okay if it starts with 2 underscores and ends with 2 underscores, and you have the a word in there with a uppercase, lowercase d, which is usually regular, those special names. Usually they don't have underscore in there. So that's the special method names you don't want to check, but everything else you want to check. That's why we have this small helper if it's a special method or not. And then you can do the same pattern here again. I just look for the methods, so I don't care about the other attributes you're going through. And if it's not a special method name, so if it's a method but it's not a special method name, then I just get a docstring and do the same kind of thing. And this is something I do strip. So if somebody just gives me an empty docstring, they can trick me with an empty docstring. Yeah, I don't check the content. If somebody puts 5 X's in there, then it's still going to work. And then if it's less than my 5 characters, I raise an exception. This is too short, otherwise I keep going. That's something you can do. So you can access the docstring, and you can check doc strings here, and I just raise this no doc string exception, which I just came up with here, defined up there, just the name, and then you do this. And this has a nice doc string, so we have this new meta class here, you have a nice doc string, and this works. And this one, it's okay. This one is too short, so if they have no doc string, or you have too short a doc string, we can comment this out here to see just there's no doc string. Then you will see an exception at this place. So if I execute this, so you see, then you see this exception here. This one works, and then the minimum, then you get exception. The minimum length is 5 characters, so you get this no doc string exception at this place. That's this one. And if I comment this out, or make the doc string longer, so that's good enough. And I have this method here without a doc string. I should always also get no doc string. So I have a variation at this place. Yeah, of course I have this no doc string. If there's no doc string, no doc string. But this one should be fine here, because this is a special method, and the special method should work, and there's no exception because it applies to the special method name. So if I put an underscore in there, I should give an exception, because now the regular expression doesn't fit anymore. The underscore is not allowed in the name, for instance. So that's something you can do, and that's something you can do with meta classes. In the wild, there's some meta classes out there, like if you know SQL Alchemy, they use meta classes and they use descriptors. And this is a pretty good use case, because you're using Python to work with databases, and then it can be pretty useful to do quite a bit of magic, because you change the behavior quite a bit, what Python is doing in the background. And then meta classes can be useful, and a few other frameworks use meta classes. Some frameworks that are older use meta classes, where they nowadays could use other measures, like what I said, class decorators or things like this, would probably do at least part of the trick. At some places, this is something you need to try out yourself, but at least it should give you some hints what you can do with meta classes. Any more questions? Good. So then you survived it. I have a few things. This is the solutions. All the solutions I showed you can download from here. And there's another one. I show you another. It's people. The organizers would like you to fill out a survey about tutorials. So this is the first URL for the solutions, and the other one is this one for the survey. This will be the same, I think, for all. So if you attend more tutorials, you have it already, and you just chose the one you just attended and just give them feedback. Then maybe we can improve something for the next tutorial. So I keep those. Maybe I put both of them in one. That's maybe easier. Yeah. Then we have to switch back and forth. So the first one is a survey, and the second one is a solutions for this descriptor and meta class part, both of them. Good. That's it from my part. So I expected a few more questions. Typically, in the I teach the things in some advanced classes. There's quite more questions, but it seems like because the crowd is so big, if the crowd is smaller, you typically there are more questions because people want to know something. So thank you very much for being here. I will stick around. If you have more questions, you can come to me personally, ask me questions. That sometimes happens right now or during the conference. I will stick around for the whole conference till next Monday. So if you see me, you can just grab me and talk to me if you like. Otherwise, I would say thank you very much for being here, and hope you have a nice conference. And there's 3 more potential tutorials you can attend, and a lot of nice talks later on. Thank you very much. So please go to these links, download the solutions, and also give your opinion on this survey.